So we're closing with a little bit of a different topic. This is about machine learning specific data debugging. So machine learning is a big hype, as we've seen at the conference, and there's some breathtaking advances. But if you look at machine learning in the real world, at real machine learning deployments, there's actually a lot of problems and a lot of data-related problems. And in contrary to Hans, I think this is something that the data management community should work on. So in the recent years, a lot of machine learning specific data debugging methods have been developed. Because very often the problems with these machine learning systems or these machine learning pipelines are actually problems with the input data. So these data debugging methods typically identify some kind of subset of the input data that has either poor accuracy, a negative impact on fairness, or maybe some low quality, like a lot of label errors. And a problem with these methods is that they are designed for this academic Jupyter notebook use case where you have a single static input data set that is small, that fits in memory, that you work on your notebook, and that already has the relational input data and features and predictions in matrix form aligned. Now, if you actually want to apply these debugging techniques to end-to-end machine learning pipelines where the actual problems occur, then that's really, really difficult because these pipelines often do not expose or store the required intermediate data. And as a result, there is a lot of real-world pain. So data scientists typically construct appropriate evaluation data sets for each pipeline and analysis. That takes a lot of effort, and this is either never done or it's only done at development time. So the question that we asked ourselves for this piece of work is whether we can work towards automatically applying such debugging methods to machine learning pipelines so that it's easy to run them and that they would ideally be applied in the same way as unit tests or continuous integration. And I can only sketch the solution here for the sake of time. So this builds on some recent work that we presented at CIDR a couple of years ago, where we treat certain classes of machine learning pipelines as data flow texts that take multiple relational inputs and then execute something like a select project join query to turn these inputs into matrix outputs, features, labels, and predictions. And as we've shown, it's relatively easy and performant to compute record-level provenance during the execution of these pipelines. And what we show in our prototype is that if we take these relational inputs and we also store the matrix outputs and the provenance polynomials in a database, then it's relatively easy to generate what we call evaluation views based on these provenance data. And then we can make it very easy for data scientists to run certain kinds of analysis. So we have some examples on how to materialize custom evaluation data sets for external debugging libraries from these views, for example, for fairness libraries. And it also turned out that in many cases, you don't actually need special libraries. Many of these debugging techniques can be formulated as certain aggregation queries and directly run on this data. We have a prototype implementation, which is available this link. We use DuckDB for capturing these intermediates, for generating the views, executing the queries, and we implemented this for pipelines from Pandas and scikit-learn, and also PySpark and SparkML. Thanks.